Hi guys, let's take a look at this problem. We do know that a fossilized bone has this much remaining. So 30% of the C14 of a live bone, okay? Now we want to estimate the age of the bone, and we do know the half-life. So in this case, we are talking about exponential decay. The half-life, this information gives us a way to find the constant k. So here's the model: y equals c times e to the negative kt, where k is a positive value. We don't really care about this c because we already know the 30%. So therefore, we do know this is going to be 30% of your initial amount c, right? Equals c times e to the negative kt. And here the c can be cancelled. So we are talking about this equation here. So 30%, which means 0.3, equals e to the negative kt. And what we need to find this t. This is the age of the bone. Before we can do that, we certainly need the k. So now we are going to use this information to find the k. Right? So now half time, if you remember, half time is equal to natural log of 2 divided by k. And we do know this is equal to 5,730 years, which implies k is equal to natural log of 2 divided by 5,030, which is really a small number here. But anyway, I'll continue. I'll leave you to finish this algebra, so find it. Okay, now go back to the equation that we just derived, like this one. So 0.3 equals e to the negative, okay, now what is k? K is natural log of 2 divided by 5,730 times t. And then we are going to apply natural log to both sides to solve for t. Therefore, I have natural log of 0.3 equals negative natural log of 2 times 5,730t. So eventually, t is equal to, so cross multiply, negative natural log of 0.3 times 5,730 divided by natural log of 2. So, and this will be the age of the bone. Okay, so this is, well, again, I skipped the algebra, but you can quickly find this algebra. I'm not going to worry about this negative sign because this is going to be negative. This is going to be negative. So therefore, it will cancel out with the negative sign in the front. It becomes to positive. So this is it.